This video will deal with the quotient rule. First we start with what exactly is a quotient. A quotient is just a divide. This is a dividing line. If we have two functions, f and g, f is on the numerator and g is on the denominator. This is a composed function, f divided by g. We can differentiate this with respect to x using the quotient rule. So when I write down the derivative with respect to x of these two functions, which are functions of x, I'm just going to simplify it by writing f over g, so that I don't have to keep writing brackets with x on the side. So the derivative of f over g using the quotient rule is f dashed, that's the derivative of f, multiplied by g left alone, subtract f left alone, multiplied by the derivative of g dash. All of that is divided by the function g squared. Note that there is not a derivative on the denominator. That is the quotient rule. Example 1 on page 14 gives us the function y equals 5x squared over 3x subtract 1. So the numerator is f and the denominator is g. So if we find the derivative dy dx using the quotient rule, we take the numerator and differentiate. So the numerator is 5x squared, differentiate that, we have 10x. We multiply this by the denominator left alone, 3x minus 1. Then we subtract the numerator left alone, 5x squared, multiplied by the denominator differentiated. So the derivative of 3x subtract 1 is only 3. Now all of that is on the numerator. I didn't have room to make it one whole line, but we divide everything there by g of x, which is 3x subtract 1, put this all in a bracket and raise it to power 2, square it. Now it's just a matter of simplifying. The first term, 10x bracket 3x subtract 1. The second term we can simplify as negative 15x squared. And divide all of that by 3x subtract 1, all squared. Now it might be possible to simplify some of the terms in the numerator if we multiply out the brackets, so we'll do that just now. 10x multiplied by 3x is 30x squared. 10x multiplied by negative 1 is negative 10x. Then we subtract 15x squared. It was there already. Divide that whole lot by 3x, subtract 1, all squared. Look for terms to collect in the numerator. 30x squared subtract 15x squared is 15x squared. Subtract 10x. All upon 3x subtract 1 all squared. Now it is possible to carry on a step further as in your book and take the common factor of 5x from the numerator to finish off. We'll go on to example 2 on page 15. So we're given y equals sine x divided by x cubed. So the top, this is a function f, the denominator is a function g. So to find dy dx, differentiate f. Now remember the derivative of sine is cos. And we multiply that by the denominator, which is x cubed. Careful, your x's and multiplies don't look the same. Now we subtract f left alone, which is sine x, and the denominator differentiated. So the derivative of x cubed is 3x squared, all divided by x cubed all squared. Tidying up the terms, we can write x cubed before cos x, that's the normal order. Polynomial first, then trig function. X cubed cos x, subtract 3x squared sin x, all divided by x cubed squared. Remember rules of indices, x cubed times x cubed is x to the power of 6. Now it's possible to simplify by taking the common factor of x squared from the numerator. So we take x squared, open brackets, x cos x, subtract 3 sin x, and all divided by x to the power of 6. Now we can cancel x squared from the numerator and denominator, which leaves x cos x on as the first term in the numerator, subtract 3 sin x, all divided by x to the power of 4. Example 3. This is page 16. This is I think this is supposed to be the function e 3x plus 2 all upon 4x subtract 1 cubed. This is supposed to be equal to y. So differentiate using the quotient rule. The numerator is f and the denominator is g, remember. Differentiate the numerator, so I'll write dy dx is the answer. Differentiate the numerator, so 3 multiplies e to the old power 3x plus 2, that's the differentiate e, and multiply by the denominator left alone, which is 4x subtract 1 cubed. Now subtract f left alone, which is e to the 3x add 2, multiplied by the derivative of the denominator. So this is the chain rule, 3 bracket 4x subtract 1 from the power gives you 2, and remember to multiply this by 4 because that's the coefficient of x. All of that is divided by 4x subtract 1 cube squared, so that's the power of 6. Tidying up the terms a little bit, we've got 3, I'm going to put the bracket before the exponential, 3 bracket 4x subtract 1 cubed e to the 3x plus 2. Second term, we've got 3 times 4, which is 12, and I subtract 12 bracket 4x subtract 1 squared e to the 3x plus 2 all upon bracket 4x subtract 1 to the 6. On the next slide I'm going to take a common factor of 4x subtract 1 squared, this bracket. I'm going to take a common factor of 3, because that appears in both terms, and a common factor of e to 3x plus 2. This is the highest common factor of term 1 and 2 in the numerator, so I'll take those out to factorise. The highest common factor is 3 bracket 4x subtract 1 squared e 3x plus 2. That appears in both terms. Open brackets, we have to decide what we put in here. Go back and have a The first term also has 4x subtract 1 bracket. So it would have been 4x subtract 1. The second term is subtract 4. So that means negative 4 times 3 is 12. So if we take this bracket here, we just have to tidy it up a little bit by multiplying it out. Don't forget the denominator is still 4x subtract 1 to the 6. And we'll just continue. 3 bracket 4x subtract 1 squared e to the 3x plus 2. Multiply the bracket. 4x subtract 1 subtract 4 is 4x subtract 5 there. Divided by 4x subtract 1 to the power of 6. So on the numerator now we've got 3 times a bracket squared times e times another bracket. So that means we can cancel 4x subtract 1 squared from the top and the bottom. So 6 drops to 4, that's rules of indices. Our final answer is 3. We can put the bracket first, 4x subtract 5 e to the 3x plus 2 all upon 4x subtract 1 to the power of 4. Example 4 on page 17. We have the derivative of tan. So if y is tan, we can express tan as a function of a quotient sin x divided by cos x. So using the quotient rule we can find out what the derivative of tan is. This is useful if you ever forget and it's not on the formula sheet. Differentiate sine, that's cos, multiplied by the denominator, left alone. Now we subtract the derivative, the numerator on its own, sin x, multiplied by the denominator differentiated. The derivative of cos is negative sine. Divide all of that by the denominator squared, which is cos squared x. Now tidying up the numerator, we've got cos squared x, negative and negative multiplied gives a positive, sin squared x divided by cos squared x. Now the numerator is a special formula. Cos squared x plus sin squared x equals 1. So we have 1 over cos squared x, which is sec squared x. Remember, 1 over cos is the same as sec. So 1 over cos squared is the same as sec squared. So the derivative of tan is sec squared x. Just write that out. Derivative with respect to x of tan is always sec squared x. This is very useful going on to maths 4.